Hello guys, in this video we are going to understand the concept of Newton-Raphson method, which is the third part of solution of transcendental and algebraic equation. It is in the numerical method. Okay, this is the method by which we can find the root more easily than bisection method and regular falsy method. If in the question university exam, if a question is asked whether you have to you have to find the root of a given equation, you may use Newton-Raphson method because it is more easy than regular falsy method and bisection method. Okay, if it is not included, that you can use the only bisection or regular falsy method. You can make easily any question of solution of transcendental and linear algebraic equation by Newton-Raphson method. Here it is graphical representation of Newton-Raphson method. A curve y equal to fx is drawn. Okay, here it cuts at A. It cuts at A. A tangent is touched to the curve at A, which coordinate is x naught and fx naught. Fx naught is y naught. Okay, initial value of y. Here you see the curve. Now we see how the formula is derived and what is the formula by which we can find the roots of the given equation. Here, theory and concept of Newton-Raphson method. Finding the formula of the Newton-Raphson method. Equation of tangent. We know that if 2 points are given and slope of the line is given, then we may find the equation of the straight line. Tangent in the previous graph we have seen that tangent is also a straight line. It is passing through one point and has slope m equals dy by dx, and the equation which is given y equal to x cube plus this anything which is, it will be made when we differentiate it will become the m. Here equation of tangent passing through x-axis is y minus y1 equals dy by dx x minus x1. Here dy by dx equals m equals slope of the line. At x-axis y equals 0, y1 equals fx naught, dy by dx equals fx naught, f dash x naught, x equals x1. Okay, substituting these values we get minus fx naught equals to f dash x naught into x1 minus x naught. On solving them we get x1 equals x naught minus fx naught f dash x naught. Okay, fx naught by f dash x naught. Here x1, it is the first value, which means first approximate value. Then it will be made by changing the values, just like x2, x3, x4. If here x1, in the place of x1 if there is x4, then here x in the place of x0 there is x3. Okay, here value is decreasing, 1 decrease, just here 1, here 0, 1 is decreasing. So generalization of this formula is xn plus 1 equals xn minus fxn by f dash xn. Okay, here n is the times number of approximation what we take. If we take the first approximation, then n equals 0. If we take the second approximation, n equals 1. Okay, it is changing. Okay, it will change. Or for finding the root of equation, what we have to do? We have to find the approximate value. Till then, when the value of the 2x, x1 or x2 or xn minus 1 will become equal. Okay, this can be easily understood by an example. Let us see an example and understand what is Newton-Raphson method and how we can use it in example, and how we can easily solve any question of transcendental equation or algebraic equation. Just remember one thing, you have to have a scientific calculator with you because its calculation is so lengthy. Okay, Before doing the question, we have to see the working rule of Newton-Raphson method. What we have to do for it? Just like the bisection method and the regular falsy method, we have taken 2 points. Okay, just like the regular falsy method and bisection method, we have taken 2 points A and B such that FA into FB is lesser than 0. Here also we have to take the A and B by hit and trial method. Okay, first approximation is x1 equals x0 minus fx0 by f dash x0. It is the first approximate value, and further by this formula, by substituting the value of 1 by 2, 3, 4, we can find the more approximate value. Okay, and we have to define x0. Here x1 is the value we have to find from x0. x0 is what? x0 is a plus b by 2. What is a and b? A and b are the two values such that fa into fb is lesser than 0. Okay, here x0 is a plus b by 2. Just remember this. Now we solve a question. By this you can understand very easily that what we have to do to find the root of an equation. Here, find the root of the equation x cube minus 3x minus 5 equals 0 by the Newton-Raphson method, correct up to 3 decimals. Okay, by working rule we have learned that given fx equals 0, by hit and trial method we have selected the two values, just like at x equal to 2, f2 equal to minus 3, a lesser than 0, and at x equal to 3, f3 equals 13, which is greater than 0. So here f2 into f3 is lesser than 0. The second condition fulfills that. fa into fb lesser than 0, it fulfills that. Now we find f dash x. What is f dash x? It is the differentiation of fx. Fx is what? X cube minus 3x minus 5. Differentiation of x cube gives 3x square. A differentiation of minus 3x gives minus 3. Okay. Here x0 equals a plus b by 2. What is a? A is 2, b is 3. A plus b by 2. Okay. x0 is a plus b by 2. x0 equals 2.5. Okay. Here x0 equals 2.5. Now we find the first approximate value. Okay. Here the first approximate value is, substituting the value of x0 in the formula, x1 equals x0 minus fx0 by f dash x0. By the scientific calculator, we substitute the value of f dash 2.5, just like 2.5 whole cube minus 3 into 2.5 minus 5, and f dash 2.5, which means 3 into 2.5 whole square minus 3. Okay. Just on calculation you may do easily by, if you have a scientific calculator or a calculator in the scientific calculator in a mobile, you can easily do. But in examination you have to have a scientific calculator. On calculating the value of x1, we get x1 equals 2.30158. Okay. What we have to do next? Think, just when the two values of x becomes equal, then that is the root of the equation. Understand? Then we find the second approximate value. x1 is given. Second approximate value, x1 equals x2 equals x1 minus fx1 by f dash x1. Substituting the value of x1 equals 2.30158 in the equation, fx equals to 2.30158 whole cube minus 3 into 2.30158 minus 5. Substituting that value, we get x2 equals 2.7929. On third approximate value, finding third approximate value, we get x3 equals x2 minus fx2 by f dash x2. Okay. Here x3, on calculating this, here x3 equals 2.7901. Okay, you may get it. Here, finding the fourth approximate value, x4 equals 2.27901 minus f 2.27901 by this. x4 equals 2.27901. Here x3 equals x4. So the root of the equation is 2.27901. Here it may little bit differed, but it may little bit differed at the last decimal position. But in the question it is given that you have to solve the you have to find the root of the equation up to 3 decimals. Here 3 decimals is 279, 2.279. Hence the root of the equation is 2.2790. Okay. If you find any difficulty in understanding this, please comment in the comment section. Okay. It is very easy method, either than regular falsy method and bisection method. In that method we have to find several values. In this method it is not so lengthy, it is easy, it is not so messy. Okay, we didn't have to calculate more. In one formula we substitute the value and get the answers. Okay, in my view it is a easy method. What is in your view? Which method is easy for you? Please comment here. Okay, thank you for watching this video. Like our video if you like it. Subscribe our channel for on this topic. In our next video we will talk about Bernoulli's equation, question number 9, 10, 11, 12. Okay.